Okay, Coroneos 100 integrals number 20. This question, we have x on square root of x plus 1. So that's a pretty hard question here. If you look at this question, the derivative of the denominator is not equal to the numerator, so you can't use the ln to integrate it. I don't think you can use the reverse chain rule, like fx to the power of n, to integrate it as well. So what we need to do is we're gonna use something called an algebraic substitution. That square root of x is really annoying. So how about we replace that? Okay, we sort of need to simplify this. So we're gonna replace it. This time, what I need to do is we're going to let u equals to square root of x. So we're going to replace that entire square root of x. Okay, you don't want a square root of x to be here. So therefore that gives you like x to the power of half. Okay, so once you finish this one here, then what we can do is differentiate it to both sides. So we'll get du is equal to half x to the power of negative half dx. Okay, but still this is a bit annoying, but just reading this one here, it looks like it's pretty crazy. You've got x to the power of negative half here, you've got a 2. So what I need to do now is do some algebra simplification. Let's first move the half to the left hand side. So you end up with 2 du is equal to 1 over square root of x dx. Once you finish that, let's move the square root of x to the left hand side again. So you've got square root of x and 2, du is equal to dx. Now it's really simple. We've got dx here on this side, and this is what you want to replace that dx. But then we still have a problem. That's a square root of x. So on the left hand side, you've got x, and that's a u. Okay, so what we need to do is replace that square root of x again. But again, previously we just let u equals to the square root of x. So therefore, that square root of x now can be replaced by simply u. So we end up with 2u du is equal to dx. This is the preparation that you need. All right, just to use. All right, just to do this question here. Okay. All right, next. Now what we need to do is start to do the substitution. But before we do that, we still need to work out what is x equals to. Since we know that u is equal to square root of x, right? So therefore, if we square both sides, we know that u square is equal to x. And we need that to do the substitution as well. Okay, so let's start with the question. The numerator, that x, is what we have here. So we've got u squared. So let's just write down u squared on the top. Over the square root of x is just u plus 1. Now the dx, we multiply by 2u du. All right, please remember that dx is just what's here. All right, that becomes 2u du. All right, now after we simplify it, we take the 2 outside. The numerator, you get u to the power 3 over u plus 1 du. Okay, so we simplify the fraction in such a form where the numerator is, the power of the numerator is larger than the power of the denominator. So this time what we're going to do is use long division to separate that fraction. Okay, so let's start with the long division. So we've got u to the power 3, and I'm going to divide this one by u plus 1. Okay, so the first one we're going to get is u squared. So we've got u to the power 3 plus u squared. Okay, now remember they're all just empty, which is just 0. So if you do long division, you end up with minus u squared. So we're into minus u. Look at minus u squared plus, minus u. Okay, again, remember there's another 0 here, which means, you've got another 0 here. So if you subtract from the top term minus the bottom term, you get u. All right, so once you finish that, we can continue with this with plus u here. So plus 1 here, so you end up with u plus 1, and then that becomes minus 1 as the final answer. So therefore now, what we can do is, after long division, we have changed our fraction into u squared minus u plus 1. And this is just the numerator, which is the quotient, not just this part here. And then what you have to do is you have to write another fraction plus minus 1, and that minus 1 is the remainder, which you get from there. Okay, this is just about polynomials. You should be able to do this one without any problems. Minus 1 over the denominator is going to be the divisor. Okay, so therefore it is just this one, u plus 1. So we're going to write u plus 1 here, u plus 1. that's just the u plus 1. So hopefully you understand the relationship between the divisor, the dividend, the quotient, and the remainder here. All right, so that gives you du. All right, so now it's much easier to integrate this now, okay? So we can integrate this term by term. All right, so let's integrate this one here. Yeah, when you integrate u squared, that gives you 1 on 3 u to the power 3. When you integrate u, that just equal to half u squared and plus u. And that one there is just minus ln absolute value of u plus 1 absolute value. So this is what you have, plus c at the end. Okay, once you finish that, we just need to substitute everything back. All right, we need to replace all the u by x. So again, remember what's u equals to. So we let u equal to the square root of x. So therefore, u to the power 3 is equal to x to the power of 3 on 2. And u squared is just equal to x. All right, so that means here we've got a 1/3 u squared, which is x to the power 3 on 2 minus half u squared, and that's just x, and plus the square root of x, minus ln absolute value of square root of x plus 1 plus c. That becomes the final answer to this question there. All right, this is it's a pretty hard question because you don't know, they don't tell you what substitution you need to use. Most likely you probably need to try a few times before you can get to the right substitution. The idea behind it is you do need to get rid of the square root of x. Okay, so replacing the square root of x by just a u will make your the fraction a bit easier to simplify towards the end. But of course, once you get this fraction here, you also need to know that you need to use the long division to break the fraction into two parts, where the first part is really easy to integrate and the second part is just normal integration with a log function there. Okay, thanks for watching.